Hello everyone. Today we are going to analyze this frame using cantilever method. In this frame, the columns are assumed to have equal cross-sectional areas. This is a single bay and two-story frame. In this frame, there are two lateral point loads, 20 kN in the point E and 10 kN in the point C. Let us see the assumptions in the cantilever method. The points of contraflexure in both the vertical and horizontal members are located at the midpoint of each member. The axial stresses in the columns are proportional to their distances from the centroidal axis of the frame. Let us name the center of the columns in both of the stories. In this frame, we have only one bay, so the center of gravity lies in the center. To find the center, we have to divide 5 by 2. When we do that, we will get 2.5. Now let us split the frame into two parts. From the center of the columns in the top story, let us take the upper part. Let us keep the axial force in the point G as Vg and the axial force in the point H as Vh. We know that on the left side of center of gravity, the axial force will be tensile and on the right side it will be compressive. Here we have only two axial forces, Vg and Vh. In this case, the values of Vg and Vh will be same, but there is only one difference. Vh is acting upwards and Vg is acting downwards. Now let us take moment about G. In this case, we are moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. VH is acting in the anti-clockwise direction, so that will be positive and the distance is 5, so 5 VH. This load is acting in the clockwise direction, so that will be negative and the distance is 2. Finally for VH we are getting 8. We know that VH and VG will be having the same value, but VG will be acting downwards. We have calculated the axial forces just above the center of the columns. Below the center, they will be acting in the opposite direction. Now let us split the frame into two parts. From the center of the columns in the bottom story, let us take the upper part. Let us take moment about I. Vj is acting in the anti-clockwise direction, so that will be positive and the distance is 5, so 5 Vj. This load is acting in the clockwise direction, so that will be negative and the distance is 6. This load is acting in the clockwise direction, so that will be negative and the distance is 2. Finally for Vj, we are getting 28. We know that VA and VJ will be having the same value, but VA will be acting downwards. We have calculated the axial forces in the columns. Using the axial forces, we can find the shear forces in the beams. First, let us find the shear force in the beam EF. For that, let us take the joint E. Let us apply the rule sigma V is equal to 0. 8 is acting downwards, so that will be negative. Let us keep the unknown shear force as V. It is acting upwards, so that will be positive. Finally for V, we are getting 8. Let us apply that. Now let us find the shear force in the beam CD. Let us take the joint C. This force is acting upwards, so that will be positive. This force is acting downwards, so that will be negative. V is acting upwards, so that will be positive. Finally, for V, we are getting 20. Let us apply that. Now, using these two shear forces, we can find the moments. We know that the moments in the columns will be acting in the anti-clockwise direction, and the moments in the beams will be acting in the clockwise direction. First, we have to find the moments in the beams. For that, we can use the formula WL upon 2. In the beam EF, we have to find the moments MEF and MFE. Here, W is 8, L is 5. When we apply the values in the formula, we are getting MEF and MFE. Now let us take the beam CD. Here we have to find the moments MCD and MDC. Here W is 20 and L is 5. When we apply the values in the formula, we are getting MCD and MDC, which are 50. Now let us find the moments in the column EC. If this moment is 20, MEC also should be 20. If MEC is 20, MCE also should be 20. So MEC and MCE are 20. Similarly, if this moment is 20, MFD and MDF also should be 20. Now let us take the column CA. We can easily find MCA and MAC by subtracting this moment by this moment. When we do that, we are getting MCA and MAC, which are equal to 30. Now let us take the column DB. Here we can find MDB and MBD by subtracting this moment by this moment. When we do that, we are getting 30. In this analysis, we have calculated all of the moments. We have calculated the shear forces in the beams. Now let us find the shear forces in the columns. First, let us find the shear force in the column EC. For that, we have to add these two moments, so 20 plus 20. Then we have to divide by the height 4. When we do that, we will get 10. Now let us find the shear force in the column FD. For that, we have to add these two moments, so 20 plus 20, and then divide by the height 4. When we do that, we are getting 10. Now let us find the shear force in the column CA. For that, we have to add these two moments, so 30 plus 30, and then divide by the height 4. When we do that, we will get 15. Now let us find the shear force in the column DB. For that, we have to add these two moments, so 30 plus 30, and then divide by the height 4. When we do that, we will get 15. We have calculated the shear forces in the columns and beams. We have already calculated the axial forces in the columns. Now let us find the axial forces in the beams. For that, we have to use the shear forces in the columns. The axial forces in the beams will be compressive. Let us take the joint E. Let us keep the unknown axial force as H. 20 is acting towards the right side, so that will be positive. 10 is acting towards the left side, so that will be negative. H is also acting towards the left side, so that is also negative. Finally, for H, we are getting 10. Let us apply that. Now, let us take the joint C. This 10 and this 10 are acting towards the right side, so both of them are positive. H and 15 are acting towards the left side, so both of them are negative. Finally, for H, we are getting 5. Let us apply that. We have calculated all of the axial forces. Now, using the movements, we can draw the bending moment diagram. Now, we are going to end this session. Thank you for watching this video.